Alright guys, another update. Someone made a great point on YouTube. Wasn't thinking when I did this. I should have a bus bar, which I'm going to use this for now, just because I have nothing else really. But that'll hold the current, no problem. And I'm going to solder these connections on this bus bar temporarily. Then I'm going to solder the inverter line to the end of the bus bar, so the current is more shared. And not only that, I'm putting 15 amps of fuse per BMS. I have to use two of these fuses because 7.5 amps each, using 2 in series. That's what I got on hand, so that's what I'm using. We have a heater running off a 1000 watt inverter. It sounded funny a second ago because this fan doesn't like the cold, and it's just keeping me warm, running off the big gel bank. Gel bank's doing good. Yeah, so I'm gonna get to that and I'll show you guys what it looks like after. So I decided not to use those 7.5 amp fuses. I'm gonna go out and get some 20 amp fuses so I don't have to put two together. That's how I got it soldered up for now. Each wire is a different BMS negative going through 100 amp fuse, and yep, that's the only modification. The extra that I got tonight was the main fuse, which well, that should not blow unless there's catastrophic failure, which yeah, these wires I know for a fact can push over 33 amps each. This is 2 sets of 12 gauge, so it would have the capability to burn that out. But tomorrow I'm going to go out and get some 20 amp fuses for this, because I want to do this a lot safer. I thought I had some on hand, but I didn't, so that's what we're going to do. And we can turn the unit back on. We're hooked up through that little temporary bus bar I just made. What's going on here? Okay. Taking 160 watts, 120 volts, 119 volts-ish. Shut this off. Give this unit a little bit of a test. Let's see, that's soldering iron. Let's turn this off. Now this isn't going to be going through the watt meter, but that is hooked up into the inverter. Now, and it says 107 volts there, but actual voltage is 112, 111. It's acceptable. This is what the house is taking inside, and this is the cord coming down. Where'd the cord go? Hold on, it went behind. Okay. This is the cord going into the heater. That is 1500 watts. Now let's try, 700 watts. Let's try 1500. It's working. So this is 1500 plus whatever's in the house. Let's get the voltage. 113, 119. It's pumping around a little bit. It's definitely pumping out some heat. Now we're going to go for temperature test. Everything. This is the heaviest load I've had on this yet, so I want to make sure everything is going to be okay. I'll be back and get my amp meter. Alright, got the amp meter hooked up. Got 32.7 amps getting pulled out of this battery bank. Nothing's even a tiny bit warm. Nothing at all. Nope. Everything looks like it's really good. These are just temporary clamp-ons. Temporary clamp-ons. But yeah, looks great. We are sitting at 59.8 volts under load. I'm going to turn it to fan. There's your voltage fluctuation, 1500 watts. And back on. And then off. Back on. Off. Back on. Anyways. Yep. Working pretty good. Now I'm going to wrap this in the electrical tape all the way around, all the way through. Wrap this side as well. And that's my temporary modification. It's working extremely well. I think I need about 1,000 watts of solar on this project. I'll be using both of those for charging, and I'll get some real usable power out of this. Right now I can only test because no sun. We only get about 8 hours of sun a day right now in the winter, and on top of that, it's we hardly ever get any sun at all. It's just cloudy, snowy, rainy. It's not cold enough for it to rain or snow all the time for snow to stay. So until middle of January or whenever it is, that's when we start getting some good or some sun again. Anyways, thanks for watching, guys. Decided that if I left it there, this would be a boring video. So I'm going to do an extreme test on this inverter and the BMS boards and this little system I got going to make sure it's going to be able to handle what I want it to be able to handle. Got my clamp meter ready to catch whatever inrush I get. This is it won't pause. We're gonna have to just watch it, and when the inrush goes, see what it takes. But we're gonna turn the 1500 watt heater on high. I'm gonna turn the compressor on while everything in the house is on, which is only taking 100 watts at the moment, but that's okay. So let's start. And note we are sitting at 60 volts, 61 volts. And here we go. So there's what the inverter is taking from the batteries. And I'm curious to see if this is going to even start up. I haven't tried an extreme test like this yet, as you can see. Someone was calling me, so let's start this test again. Inverter is pulling around 2-ish amps. Let's see, watts. So 1 amp. Makes sense that it's about doubled at 60 volts. We're going to run everything in the house, so 100 watts approximately. 104. Plus the heater on high. Alright, so that we're at 59.8 volts. Then we're going to see if it will start this compressor. I hope it doesn't blow all the fuses in this inverter, but we'll see. So here is, we're going to try and catch the inrush current. Here we go, 1, 2, 3. Ah, dang it, it went over 40 amps and I missed it. So I got it set to 40 amps. I should have thought about that. Okay, now let's try that again. Let's see what this thing can actually do. Wow, that went over 50 amps for a second. That's impressive. You don't have to worry about my ring, it's rubber. Wow, that is impressive. This inverter just keeps impressing me. So it's outputting, well, it was consuming 50 amps. So we have 1500 watt heater. And to start this compressor, I don't know if what I saw was right. It was like 58 amps or 56 amps. We'll do it one more time. Look at that. And something started in the house. We're taking, oh, it's up to 500 watts there for a second. Now we're 160 in the house, 1500 watts here, plus this. So let's see what we get this time. Anyways, oh, let's leave it on for a sec here. 50 amps. Everything's nice and cool. This bar is slightly warm. Just slightly. You can feel it. Just checking everything still. No heat in any of these diodes or MOSFETs or whatever they are. I know they're only using 2 prongs, so I must see some sort of diodes. Look at that. It's doing really good. Wow. Let's see what this is saying. Wowee. Oh, you know what happened? Here we go. Looks like we have ice buildup or something in here, because this release valve just blew and scared the crap out of me. Anyways, oh, that's awesome. This system can handle quite a bit. Inverter is slightly warm to the touch. Fans are not on yet. Well, all I can say is I'm thoroughly impressed with this inverter. For $360, I don't know. I don't think you can buy anything better for $360. Anyways, thanks for watching, guys.